welcome to LADYADA.
Hey everybody, it's me, LADYADA, and it's another Sunday evening. The weather's getting chillier, so we're going to stay warm by the soldering iron and check out what's going on my desk.
Yeah, it is voting Eve, and
Yeah.
just
in the U.S.
Yeah, just a little reminder. Our team has a paid day off. Some of us will be shipping your orders. Some of us will be at the polls. Some of us voted early. If you haven't voted, make your plan. Bring a phone charger. Bring a snack. Look at the weather. Maybe go with a friend. We voted on Saturday. We voted early. We took care of everything in New
York.
It was
so fast and easy.
Yep, and special thanks to the poll workers out there. There's thousands of them in New York, and they are very helpful people. They're doing something for everyone. So thank you. If you're someone out there who used our resources, people let us know that they did, and they became poll workers after they saw our call for help around the country for more poll workers this year. Thank you very much, and we'll see how things go. So this week we have a few things. Let's first start off with what you're working on, and then we'll do a little bit of Great Search with Educate.
Okay, cool. All right, to start off, we have a thing we're going to do STEMMA Sunday every Sunday. I talk about one STEMMA board. So I can show off the STEMMA board that I just put together. So let's go to the overhead. And this is an MCP 9601. This is the next generation of the MCP 9600, which sounds like a program in Tron, but actually is a thermocouple sensor. And you can see I've attached a K-type thermocouple with a metal tip onto it. And I'm actually using this on a small hot plate to make prototypes. So it's like the prototype makes itself. It's kind of cool and meta. But what's nice about this thermocouple sensor amplifier is that it works over I2C. So I've got it here on a clue board, and I love the clue because you can just plug in STEMMA QT boards, and I've got like a little hot water thing. So let's see how hot this water is. Okay, getting warmer. Okay, it's like 50, 60 degrees C. So this is, we already have a version of this board, the 9600, but I designed it a while ago before we had, trying to do everything with the STEMMA QT standard, which is like 1 inch by 0.7 inch. So this board is really nice and compact. And what I like about the 9601 is that it now has open thermocouple detection. So this code actually it won't print out like disconnected, but I'm going to add that next. I just finished this up. But it can detect if the thermocouple is detached, which the MCP 9600 cannot. And a couple of people actually noticed that. They're like, oh, my thermocouple got disconnected and didn't realize that the temperature was like invalid. So what I like about the 9601 is that it will tell you, hey, the thermocouple is touching ground or it's disconnected, the temperature is invalid, don't trust my voltage reading. So that's nice toasty water. I can have some hot chocolate later. Okay. And that's the STEMMA Sunday.
All right, what else we got going on?
Okay, I'm going to unplug this. Okay, so next up, I'm working on finishing up the Feather M4 CAN board. So this is everything that you love in the Feather M4. There you go. But it now uses the SAM E51 instead of the SAM D51. The SAM E51, you might think the E is for Ethernet. You're wrong. The E is for CAN bus.
That makes sense.
Yeah, of course. All you need is a little transceiver. And then I have a 3-pin terminal block, which gives you ground, CAN L, and CAN H. I even have a little boost converter. The boost converter, and this is something I'm still trying to figure out completely, but it seems like you can run a CAN bus off of plus minus 3 volts, but you get the best interfacing quality if you have plus or minus 5 volts. And so since the Feather is a 3-volt device, I need to have a little micro boost converter. I use a switch cap converter. I love switch cap converters. They're very small. They're low cost. They work quite well. You can feed them. They're not as efficient as an inductor-based boost converter, but if you don't need a ton of current, like 100 milliamps or less, they work great. So I have, these are actually running CircuitPython. This one is transmitting data. You can see the little transmit blink. And this one is receiving data. And when I twist this knob, let me reboot this. Oh no. Oh, there you go. I had a loose wire. when I twist this knob, the color changes on the Neopixel because I'm kind of like going through like red and then purple and then blue and then green, yellow, and back to red. So this is sending a message over CAN, and you can have, you know, like a large number of CAN devices as long as each one has a unique address, which is cool. This, you know, I did make a couple changes from the Feather M4. I started with the Feather M4, but I did make a few changes. The most important one is, of course, I'm now using USB-C. And this is also making me think that I want to revise the Feather M4. It's a very popular board, but I want to revise it maybe to do USB-C, you know, based on the change. Like the things that I did to convert this, I would like backport those changes. So let's go to the computer and let's look at the design real fast. Okay, so this is my Feather M4, and like I mentioned, this has USB-C over here, still has the same battery port. Things got a little bit squished over on the left side. Oops, I keep forgetting this has to shrink. Because you know, the USB-C is just a teeny bit larger, and it requires the 5.1 k ohm resistors. We've got the same Neopixel, like little buck converter if you want to use that. 32 kilohertz crystal, and then over here you can see the transceiver connected. There's like a special set of lines for using CAN bus. You can see CAN 1RX and CAN 1TX here. This is the little boost converter. It takes whatever is higher from the battery or the USB and gives you a 5-volt out. And then here's just the breakout for the CAN bus, like the transceived signals that are actually differential. But what I wanted to do is improve the low power handling for this board, because it's something I've never really cared about. But I think with CAN bus, maybe you want to have a sensor on a CAN bus, and you want people to go to sleep and then wake up and then report a sensor reading and then go back to sleep. I think that's a likely situation. So there's a couple things to do with that. So the first step is the Neopixel. So Neopixels draw 1 milliamp quiescent, which is quite a bit. And they do it all times. Even if the LED is off, they draw a milliamp. So what I added is there's another GPIO pin called Neopixel Power. And then to turn on the Neopixel, I have to pull that pin high, and then I can write the data on like this Neopixel pin. But that means that when I'm going into low power mode, I can shut down the Neopixel. I don't have that 1 milliamp quiescent, which is super nice. Another thing is on the little boost converter, there's enable shutdown pin. Ditto, you connect that to a GPIO. When you want to use the CAN bus, you turn that pin high. When you're done, you set it low and you go to sleep, and then you don't have any quiescent. Even if there is some quiescent current here, which there probably is, you don't even have to worry about it because you've completely put it into shutdown. So it's like, you know, a microamp or two, if that. The transceiver also has like a sleep mode S, and so you can basically turn off the transceiver as well. Not only like you're not sending signals, you don't want to listen to signals, you want the chip to be off. Also connected to a GPIO pin. So, you know, basically like the Neopixel powering from a GPIO pin, some people say like, oh, like that seems like it's a lot of current, you know, it could be up to 60 milliamps. The pins are current limited. I'm not worried about it. You know, most people don't set their Neopixels on to full white, and if they do, again, the pin is current limited. It's not like you're trying to short an amp through it or something. I think also Neopixels are not truly 60 milliamps when they're fully on. I think they're more like 40. I think they're not 20 milliamps per LED segment. We also have the 32 kilohertz crystal, so you know that can be used for low power modes, although I honestly have not used it. And then there's also this like little buck converter that you can use, although I think this is only reduces your current draw when you're in like running mode. I don't think it affects sleep mode. So, and then you know there's a couple other things. So, well, the battery charging circuit, it only is powered from USB, and if you're plugged into USB, I'm not as concerned about quiescent current. So, you know, there's not much to do there. I'm going to leave this. You know, this is not disableable. Basically, it's always on. I do have this VBAT divider, which allows you to measure the battery. And, there's no real way to disable it because the high voltage is from the battery. I mean, I could add some more circuitry, but I don't really have any space. If you do the math, this draws 4 volts divided by 200K, because that's the sum of the two. And then, divided by 1,000 because it's kilo ohms. It's 20 microamps. So what I can do is I can increase this resistance. I can change these from 100K to maybe 200K or 270K. So I might do that. I'll get some resistor packs. And then there's the regulator. So, this at this point, it's I want to make sure that I can get as low power and sleep. So I should see what is my sleep current now. So I ran my power tool, which is the device I use to do current measurements. And let's run this. Oh, uh-oh. Uh-oh. Hold on. Sorry.
Ring.
Yeah.
Ring.
I went to sleep. Hold on.
Power meter tired.
I know, power meter.
Power meter tired.
Oh no, what happened to power meter?
Power meter's been waiting 4 years to vote.
Let me see if I can restart it. If not, you'll have to believe me, or I can open up. I took a screenshot in case. Yeah, okay, here you go.
Power meter back.
Power meter is back in
Power
business.
meter is Phoenix. Rise from power ashes.
So you can see here, if I go into milliamp range, 10 milliamp range, maybe 5. So, in this I have this little code that I wrote, and basically it goes to sleep for, it goes to, it wakes up, it kind of enables everything, and then delays a little bit and then goes back to sleep. So you can see the standard kind of runtime without doing anything in particular is about 20-ish milliamps. That's actually kind of right. Cortex M4 runs around 20 milliamps. And then you can see that it drops very low when it's in sleep mode. So let's check that out. Sleep mode is about 250 microamps, which is pretty good. Considering that I haven't really done any work on that. All I did was add some GPIO pins to turn off things. But I do want to try to reduce that. And the first thing I did was I have to check out the regulator, because the regulator is the only thing that is on all the time. With the microcontroller, once it's in deep sleep, it turns off all the peripherals. We're done. When I've shut down the boost converter, there's nothing more I can do with that. When I've shut down the CAN transceiver, there's nothing more I can do with that. The Neopixel, turn off the power. So the only things that are currently drawing current are the resistor divider, which I can reduce the resistance of, the microcontroller, which I'm stuck with whatever the microcontroller can do for the deepest sleep, whatever peripherals I turned off, and that regulator. And if you look up the regulator, which I love the AP2112 because it has very high current output and very low dropout. So you can do 600 milliamps minimum. It's got good accuracy. It's got enable. It's got really, really low dropout. However, the trade-off is it says low quiescent current, which I guess low is relative, but it's not that low. If we search for quiescent, they say 55 typical, but it can be as much as 80. And that's assuming that there's no current output. There is a little bit of current output, basically 80 microamps. So it's, a third of my current, maybe a fourth or a third of my current is going to this regulator. Now, this might be enough. Maybe 200 microamps is good enough. I don't know. But it would be nice to see if I could find a regulator that it was ultra low. This is low. I want ultra low quiescent current. And that's what I'm going to search for in DigiKey. Which brings us...
Let's do the great search for DigiKey.
The great search.
Where
Every single week we do the great search with DigiKey. Where in the world is that part that I need on DigiKey? LADYADA.
We're going to find out. Okay, so let's go back to my computer. Right, so we're going to try to reduce the quiescent current of my circuit. It's drawing 250 microamps in sleep mode. I want to reduce that more, but I'm stuck right now because my regulator, the AP2112, it's a lovely regulator, but the quiescent current is 80 microamps. It's low, but it could be lower, right? Maybe we can get to like 10 or less. That can make a big difference. You know, if I can reduce the quiescent current by a third or a quarter, it means it runs for that much longer in sleep mode, right? Good things. And I'm interested in that now. So let's see if we can find we're not going to find a perfect duplicate minus that quiescent current for the same price, right? Obviously, if it existed, I would have picked it. But let's see what we can do to find something close. And ideally, drop in replaceable, because then I don't have to respin my board design, although I'm willing to do that. But it would be cool if I could just swap in a different regulator and just, maybe it's a little bit more expensive, maybe the dropout's a little higher, but the quiescent is much better, and so it's great for low power usage. So let's check it out. Okay, let's go into DigiKey, and I'm going to just search for voltage regulator to start. I like to start nice and vague. And this is, by the way, the AP2112. And one thing you could do is you could go through and you could click some of these things to get a similar chip. But I actually want to be a little bit more freeform in my search. Again, there's so many different regulators, like power supply. Powers and power supplies is a huge part of engineering. But we just want the linear regulators. Now, one day in the future, maybe I'll upgrade my design to use a buck converter. There's very low quiescent buck converters, but I'm going to stick to the LDO. It's small, it's effective. My dropout is, very minimal. It's not like I have 16 volts going down to 3 volts. I'm going from 3.7 to 3.3. So I want at 200 milliamps or so, I want to not have a dropout of higher than 400 millivolts, if possible. Okay, so start out with, of course, I only want the active and normally stocking items. So let's do that, and we can cut down the quantities quite a bit. I'm going to, there's outputs you can have adjustable ones where you have a twisty, not a twisty knot, but a resistor divider. In this case, I don't know, sometimes there's adjustable and they can also be fixed, but I basically just want these. I don't want programmable, I don't want adjustable. I want it to just spit out 3.3 volts. I'm not interested in anything else. I also only want one regulator. And I want, I don't think I need to worry about this because the next thing I'm going to do is I'm going to pick that voltage output. So for adjustables, you'll want the minimum and maximum. But if you only want a fixed output, you just go to the, clicked the wrong thing. You only want the output voltage min fixed. I'm going to scroll down until I get to 3.3. There's a couple different options. So it looks like there's a couple, there's sometimes variations and stuff. But these look good. Apply. Okay, it's thinking. Great. Okay, next up, I want current output. So, I need it to be somewhat close to what I've got now. The current regulator, I've got the 600 milliamp output. 600 milliamp is quite a bit. I could live with as little as 500, but I don't want to go below 500, right? So let's pick 500 and then, we'll go up to 7.5 amp, but I know that there's no 7.5 amp one in the package I'm going to use, but whatever. You can just select it and then we'll get rid of those later. Okay, now we're up to the important part, which is the quiescent, right? So the one we have now is up to 80 max. I think I'm going to say, and it goes high quite fast. If you're not looking at the quiescent current, believe me, you get regulators with, it says here, up to 20 milliamps quiescent. And the quiescent current is the current that it draws even when no other current is being used. That's the current of the regulator itself, not the output. It's what it itself draws from the power supply. So I definitely want it to be less than 80. I actually kind of want it to be less than 50. I'm going to say 25 or less. And it looks like you can go down to 1 microamp. And you can see when you're picky about the quiescent current, you know, it tells you how many are remaining. It like drops really fast. So let's see what we got here. Okay, so there's a couple options, and normally I would, you know, sort by price. But here's the thing. So I kind of want one that is the same like size and best off, you know, if possible, the same package. So the first thing I'm going to do is there's not that many of these. I'm actually going to try to get rid of some of the ones that are like the SOT 89, which is like a larger package size. I'm not going to be able to fit that on my board. And like, especially not this. This is like a TO 263. If it's a TO anything, there's like no way I'm going to fit that on the board. So let's get rid of like the very chunky boards. So all of these TOs, sorry, you got to go. And I'm also going to get rid of the 6 SOIC. And I'm also going to get rid of the SOT 89s, because those are huge. But the rest of these might fit, right? So let's apply. So now I've got only about 27. Okay, we're doing better. So of these, the first thing I can do is, well, so the price is a little sneaky, because again, remember, that's for for individual units. And I want to compare this to the AP2112, which has a price of about like, you know, 10 to 7 cents. It's kind of another reason I love the AP2112. It's so cheap. It does such a good job and it's so inexpensive. So I want something comparable in price. And you can't search by price range, but that would be really cool if DigiKey added it. So maybe they'll be inspired. It'd be cool to say like, for that quantity, here's how much I'm willing to pay. But what we'll do instead is we'll go to the view prices at, and we'll just put in like 5,000, because I don't really care about the price individual, right? If one is 60 cents and one's $1, but when you get to the real quantity, up to real quantity, they're both basically 6 cents or 7 cents. It's not going to make a big difference. Okay, so now we're here. Well, here's the deal. I definitely don't want a BGA. I'm judgy. So let's get rid of the BGAs. So let's see all of these and then subtract the BGA. Just get that right out. Okay, cool. All right, so now we're actually looking at, you know, the pricing, and the pricing is actually not too bad. Like, you know, the AP2112 is like 10 cents. So I'm going to pay more, but I'm not going to pay like super crazy amounts, right? It's not like, I mean, it does get high. It gets up to $1. But oh, and there's the Rochester, which we can remove as well. So let's not include Marketplace, because I don't want the Rochester, which is they sell parts that are discontinued. You can still get them. Okay, and then so here's kind of something interesting. So it looks like regulators are starting to come in this package, which I've never used, but I kind of think it's adorable. It's got like big distances between the pads, but it's physically quite small. So this is interesting to me. So even though I may not use it in this particular situation because I already have the board spun out, like and done, I don't want to change it. I do find this package intriguing. Okay, so we've got a couple options here. There's 2 SOT 23.5s and some DFNs and some more SOT 23.5s. Looks like there's a bunch of SOT 23.5s, and that's the package I'm replacing. So let's just select that. Wait, I also want, sorry, I would like to TSOT, yeah, let's see. Okay, so that could give me the thin ones, the thick ones. Okay, so this is it. These are my options, which is like really nice. I've actually pared it down to like, you know, a screen full. There's only 6 options. And the next thing you can do is, again, you can't sort by price, but there's a couple options here by price. Then you can go all the way to the right and you can look at the things that might be most important for you. So for example, there's ones with like 8 microamps and 0.7 volt dropout. This one might have a slightly lower dropout, also 600 milliamps. This one's only 1 microamp and has 1 amp output, which is like really impressive. So that's but the pricing gets a little higher, like we're paying 35 cents. So I'm actually, you know, the one I actually think I like the most is this 4 microamp, 600 milliamp output. and about 0.5 volt at 600 milliamp dropout, because I don't need this high voltage range, but I like that it's only 4 microamps. Like, I think that's going to make a big difference in this situation. So I'm going to pick up some of these RT 9080s. And here's a tip if you're ever using these regulators. So blessedly, unlike many other devices, including transistors, pretty much every company that makes regulators in the SOT 23-5 package, which is a very common size, they all use the same pinout. So you can verify here, it goes V in ground, enable, and then no connect and V out. And the same thing here, V in ground, enable, no connect, and V out. So this can just pop right in. Just make sure that you have like the right, again, voltage range, capacitance, whatever things it needs. But I can actually just try this on the board. So maybe next week, by the time I get the chips, swap it in, see the quiescent current. Hopefully it should drop by like at least 60 microamps. So that will be a very nice improvement in my design.
All right. And that was a great search with DigiKey this week.
Regulator found.
Where in the world is that part I need? The great search with DigiKey.
Okay, I'm going to drink my slightly warm water.
All right.
All right,
Well,
any questions? Or
Yeah, someone was asking, since Eagle's going to be folded into Fusion 360, are you going to use that?
I don't know. I'll deal with that when it comes up.
Yeah.
I don't know yet. I've never used Fusion 360.
Okay, so are all TSOT 23.5s the same size?
Yes. The T-SOT itself, the SOT is, a certain size, like 3 millimeter by 3 millimeter, I think.
Question, pinout may be identical, but are dimensions all the same?
Yes. So the package of a device, whether it's SOIC or TO263, if it's the same package, it's the same size. The thickness may vary a little bit, but the package itself, like the dimensions and the pads, are going to be the same as long as it's a standard package. Only time I see that differ is when you have like QFNs, and like sometimes the dimensions are like, it can be confusing, like a 16-pin DFN, a 16-pin QFN. They're not always the same size. However, if it's the same number of pins and the same size, if the pins are the same and the square size is the same, the package will fit on the same pads.
Okay, I'll answer this one. Someone says, can I have a job, please? Yes, but here's how you have to do it. Publish some stuff online, preferably open source where people could see it. Participate in the community and help some folks out. And join us. Be part of this thing. That is the job application. And that's how we hired most of our folks. So if you have skills in engineering, that's always helpful. But there's lots of other things. But stick around and check out.
We hire from the community,
Check out
absolutely.
CircuitPython.org. You could take a look at a lot of stuff that's going on.
We have public meetings. We have GitHub repos. I have hired people just who do like really great GitHub pull requests. I'm like, hey, you like fix some code. Can I hire you to fix some other code?
Yeah.
It
And great and timely search. I was just trying to find a low power on the ITZY NRF52.
Well, here you go.
Yeah.
You try out one of these. I'll try out the other, and then like we'll meet in the middle.
Yeah, and folks really like it. They said DigiKey's search is powerful, but you do need to know how to use it.
Yeah. So I think one of the tricks here is like, you don't want to be too specific because you might miss something, right? You want to be kind of broad and then like learn when you want to narrow in, especially when it comes to like, because you can't do price ranges, but you can do spec ranges. So it's like, but pricing isn't, the most important thing to an engineer, right? After the specs. It's like specs, and then cost.
And then a little bit of reminder, you can go to jobs.adafruit.com and you can post your skills, and you can also look for a job there.
That's right.
And what is the power meter app that you were using?
So this is the Monsoon power monitor. I will say it's not inexpensive. It costs as much as a high quality logging power meter is, which is close to $800. I do know that there is a cool low power meter coming out in the next few months. So if you can wait, I can't talk about it, but believe me, it's really cool. When it comes out, we'll show it off, and and tell people about it. But it'll be a lot more affordable.
How many years have you been designing PCBs in Eagle?
Since like before 2005, maybe 2001, 2002.
Coming up on 20 years, I'd say.
Yeah, I started with Eagle 3 or 4. MIT had a site license, so that's why I started with that. And KiCad was not available for Windows.
Okay.
All right, thanks everybody.
All right. Oh, Parallel Logic, they said they've been using the Auto Ranger for current measurements, about $100.
Cool. Use it. Yeah, like this was, at the time when I bought this, it was kind of the only thing.
All right. Okay, everybody, that is Desk of LADYADA this week. We will see you on Wednesday, assuming there's civilization. And either way, we have a show on 7:30 Eastern Time, show and tell, then Ask an Engineer at 8 p.m. JP's show is on Tuesday, JP's product pick. Wednesday, we have Noam Pedro's 3D printing. Thursday, we have JP's workshop. Friday, we have Deep Dive with Scott. So a full week of video stuff to get your mind off what's probably
That's right.
going to be an exhausting week ahead.
If you got an AdaBox, post up some projects. We're in Discord and the forum. A lot of people are showing up because they always got AdaBoxes, but build some cool blinky stuff. And then we're going to get started on the next AdaBox soon. If you don't want to miss out, sign up because we have fewer openings than usual.
That's right.
People love this.
All right, that's Desk of LADYADA for this week. Thank
Thanks,
you, everybody.
everybody.